Okay. So we'll discuss this particular topic, minerals and energy resources, and we try to complete it. It's a 7-11. Okay. So minerals and energy resources. So when we begin this topic, we find out that a study or a kind of a short story which is presented about Haban. Haban comes to Guwahati with his father from a remote village. He sees people getting into strange houses or house-like objects which move along the road. He also sees a kitchen dragging a number of houses along with it. He's surprised and asked his father, why don't our houses move like the one we saw in Guwahati? Ba replies, these are not houses, they are buses and trains. So obviously you could have seen in the old movies during the time of 90s or 80s that the buses are having like 2 stories, and also inside the buses you would find out many of the things have been or many of the facilities have been given. So Bai replies, these are not houses, they are buses and trains. Unlike our houses, these are not made of bricks and stones. So metal like iron and aluminum are used in making these. They do not move on their own. They are driven by an engine which needs energy to work. Now this short story is given for the purpose of introducing the idea related to the minerals, and through the minerals which we use couple of objects which help us to move from one direction to other direction. So next is indicating we use different things in our daily life made from metal. Can you list a number of items used in your house made of metals? Where do these metals come from? You have studied that the earth's crust is made up of different minerals embedded in the rocks. Various metals are extracted from these minerals after proper refinement. So minerals are an indispensable part of our lives. So definitely it has association with us, right? So compulsory or called as a mandatory, right? Necessity, you can say. Almost everything we use, from a tiny pin to a towering building or a big ship, all are made from minerals. So the railway lines and the tarmac paving of the roads, our implements and machinery too are made from minerals. Cars, buses, trains, aeroplanes, these all are manufactured from minerals and run on power resources derived from the earth. Even the food that we eat contains minerals. In all stages of development, human beings have used minerals for their livelihood, decoration, festivities, religious and ceremonial rites. Now, you can draw the couple of ideas here. That's called as a minerals are highly necessary, right? So, in all stages of human beings' development, human beings have used minerals for their not only livelihood, uh, but also decoration, festivities, religious and ceremonial rites. For all these regions, we use what? Minerals, right? Next is called as, these are the couple of things that you're supposed to keep in your mind when you read. Next is called as a bright smile from toothpaste and minerals, right? So we understood from the introductory part that how daily life is made from metal, and without metals means human being cannot get into the advancement, right? So let's look into the next one, a bright smile from toothpaste and minerals. Toothpaste cleans your teeth. Abrasive minerals like silica, limestone, aluminum, oxide, and various phosphate minerals do the cleaning of your tooth. Fluoride, which is used to reduce cavities, comes from a mineral fluoride. Most toothpaste are made white with the titanium oxide, which comes from minerals called rutile, ilmenite, and anthracite. The sparkle in some toothpaste comes from mica. The toothbrush and tube containing the paste are made of plastics from petroleum. Right now, you can understand that even daily use things, daily use things are also used, means made up of with what? Natural resources or minerals, right? So whether that is talking about to pin to the ship or called as a tower, or you can use the daily product, uh, toothpaste, which is also made up of, means different minerals, right? So dig a little deeper and find out how many minerals are used to make a light bulb. It's a kind of a activity which is presented. All living things need minerals. Life process cannot occur without minerals. Means our life that continues, means because of the minerals which we use and which we, means uh, keep for the medium, right? Although our mineral intake represents only about 0.3% of our total intake of nutrients, they are so potent, so important that without them, we would not be able to utilize the other 99.7% of foodstuffs, right? So it means it is indicating we are intaking 0.3%, right, for continuously utilizing the other 99.7% of foodstuffs. Next is called as a dig a little deeper and collect nutritional facts printed on food labels. So again, another activity is indicating about nutritional facts. The earlier activity is given for the purpose of light bulb, how it is made up. Now, the next one is indicating about the great question, what is a mineral? So as we have been talking about a lot about the importance of minerals, the indispensable act or part of human's life, right? Now, at least we should know that what this mineral is all about. So based on the geologist, we understand that geologist, like somebody who research on, means geo, that called as earth, you can talk about soil, you can talk about environment, right? Geologist who define minerals is what? Now it is a homogeneous, naturally occurring substance with a definable internal structure, right? That is called as a minerals. What is that? Now, homogeneous, naturally occurring substance with a definable internal structure. That is called as a minerals. Minerals are, where do you find out minerals? Now, minerals are found in varied forms in nature. Varied means called as a different forms, right, in nature, ranging from the hardest diamond to the softest top, right? Now, this is what is indicating the example, right? Where do we find out the minerals and what are the example of minerals? Hardest diamond to the softest top, right? So why are they so varied? If you observe that, why are they so varied? You will find out that, so you have already learnt about rocks, right? So why are they so varied? Now, that question's answer we will get here. You have already learnt about rocks. Rocks are combinations of what? Homogeneous substances called minerals, right? So some rocks, for instance, limestone, consist of a single minerals only, but majority of the rock consists of several minerals in varying proportions. Means that's called as a variety of proportion is attached to it. Although over 2000 minerals have been identified, only a few are excessively found in most of the rocks. A particular mineral that will be formed from a certain combination of elements depend upon the physical and chemical condition under which the material forms. So this in turn results in a wide range of colors, hardness, crystal forms. Just a minute. Hello? हाँ, देखिए, Oh. Okay, how? देखिए ହଉ ଏଇ ପଢା ହଉଛି ବା ପାଠ ପାଠ ଓକେ ରଖୁଛି ଓକେ So what does it say here? A particular minerals that will be formed from a certain combination of elements depend upon the physical and chemical conditions under which the material forms. So when you talk about this particular part, what do you find out? A particular mineral that will be changed from a certain combination of elements depends upon the physical and chemical condition under which the material forms, right? And for which we get the result, variety of colors, the changing of soft to hardness, crystal forms, shining, luster, and the density that a particular mineral possesses. Actually, they do have with it. Geologists use these properties to, separate them or classify into the minerals. Now, look into this particular one where it is stated, study of minerals by geographers and geologists. Geographers study minerals as part of the Earth's crust for a better understanding of landforms, the distribution of mineral resources, and associated economic activities are of interest to geographers. A geologist, however, is interested in the formation of minerals, their age and physical and chemical composition. Here I would like to introduce one of the things that's called as means we are making a differentiation between geographer study and also geologist study, right? Geographer study on the one particular thing that's called as minerals. So when geographers study, so what they find out, they say that means minerals are part of the Earth's crust for a better understanding of landforms, right? So whereas the distribution of mineral resources and associated economic activities are of interest to geographers, right? So whereas geologists do what? Now they are actually interested in the formation of minerals and their age and physical and chemical composition. So basically geologists are specialized and they are interested in the formation of minerals. They wanted to know that how minerals formed and also how many years or how many decades means it take to form, and also what were the physical and chemical composition content into it. However, for general and commercial purposes, you can talk about, however, for general and commercial purposes, minerals can be classified as under. Like you can talk about how the classification occurred. Now, you would find out minerals, right, have been segregated into three parts. One is called as a metallic, non-metallic, and also energy minerals. Metallics are what? Now ferrous, right? So these ferrous containing what? Iron, iron ore, manganese, nickel, cobalt. These are called as a ferrous, and they are called as a, strong because they contained iron. Whereas metallic also referring to the non-ferrous, which doesn't contain iron, right? So, or called as the amount of iron is very less. So you can say copper, lead, tin, bauxite, these are called as a non-ferrous. So ferrous, iron contained, non-ferrous, which are not contained with the iron. So if you see that, next one is called as a precious, right? Ferrous, non-ferrous, and precious. Precious are called as a gold, silver, platinum. So these are all coming under metallic, whereas non-metallic is called as a mica, salt, potash, sulfur, granite, limestone, marble, sandstone. These are called as a non-metallic. Energy minerals, coal, petroleum, natural gas. So these are all coming under the minerals. Now, if I go for the next one, yeah. So concentration to make its extraction commercially viable. Concentration to make its extraction. Extraction means getting out. For the purpose of what? For the purpose of business is possible. The type of formation or structure in which they are found determines the comparative or relative ease with which minerals ores may be mined. This also determines the cost of extraction, right? It also indicates that means based on its getting out from the means from your surrounding, that also determines the means cost of extraction. It is therefore important for us to understand the main types of formation in which minerals occurs or minerals occur. The main types of formation, right? Minerals generally occur in these forms, right? What are the forms through which minerals are occurred? Now, in igneous, if I talk about that, minerals generally occur in these forms. The first one is called as an igneous and metamorphic rocks. So what do you mean by metamorphic? Now, meta is called as something which is beyond the body of rocks, morph, right? So in igneous and metamorphic rocks, minerals may occur in the cracks, right? Crevices, faults, or joints. The smaller occurrences are called as veins, right? The smaller occurrences, they are called veins, and the larger are called as lodes. So it is clearly indicating minerals generally occur in what? Now, igneous and metamorphic rock, right? And they how do they form? Now, they occur in the cracks, crevices, faults, or joints. So the smaller one is called as a veins, and the larger one is called as a lodes. In most cases, they are formed when minerals in liquid, right? How they are formed? Now, they are formed when minerals in liquid or molten and gaseous forms are forced upward through cavities towards the earth's surfaces or earth's surface. They cool and solidify as they rise. Major metallic minerals like tin, copper, zinc, and lead are obtained from veins, means a smaller crack or called as a smaller crevices or smaller faults or smaller joints, from which you can find out tin, copper, zinc, and lead, and also lodes, means in larger uh, larger crevices or larger faults or larger joints also we draw that. So that is why you need to keep in your mind minerals generally occur in which of the forms? You can say that igneous and metamorphic rocks. So when we talk about igneous and metamorphic rocks, we find out that through the cracks, through the crevices, through the faults or joints, so we find out veins and lodes. What are they? A smaller crack or called as means a larger one, right? So, and we also draw that what how it happens. Now, when most of the cases they are formed when minerals in liquid, molten, and gaseous, liquid, molten, and gaseous forms, they're forcing to the upwards, right, through cavities towards the earth's surface. They cool and solidify as they rise. Major metallic minerals like tin, copper, zinc, and lead can be obtained through the lodes and veins, right? So, second one is called as in sedimentary rocks. In sedimentary rocks, first one is called as igneous and metamorphic. Sedimentary rocks, a number of minerals occurs, right? Number of minerals occur where? Now in beds or layers. They have been formed as a result of a deposition. Deposition, we usually say that, right? Number of years, things have been deposited and accumulated and concentrated, right? Deposition, accumulation, and concentration in horizontal strata, right? So, a result of deposition, accumulation, gathering, so and concentration. So, rotten in condition in horizontal strata. Coal and some forms of iron ore have been concentrated as a result of long periods under great heat and pressure. So under the concentration, it's called as a great heat and also pressure. Another group of sedimentary minerals include gypsum, potash salt, and so we can draw the idea. Means in igneous rock we find out veins and lodes. In sedimentary rocks we find out that beds or layers. How do it form in a mineral igneous and metamorphic? We find out joints, crevices, faults, cracks. So in sedimentary rocks, what happened? That deposition, accumulation, concentration, right? In horizontal strata. So we find out in igneous rocks what? Now that's called as a copper, zinc, tin. And in sedimentary rocks, we find out that gypsum, potash salt, and you can talk about coal, right? These are the things. Now, coming to the next one. So yes, actually I missed out this mode of occurrences of minerals. Where are these minerals found, right? So minerals are usually found in where? Now, that's called as ores. Ores. The term ore is used to describe an accumulation of any mineral mixed with other elements. The mineral content of the ore must be insufficient. So then after we go for the description of these minerals are mainly formed in a igneous, sedimentary. Then after that it is stated gypsum, potash salt, and sodium salt. These are formed as a result of evaporation, right? Especially in arid regions, right? So the next one. So in this particular part, what do we understand that? So we understood about igneous rock, we understood about sedimentary rocks, so bed layers, right? And also certain minerals which are also formed as a result of evaporation. That's something called as a turning into air, especially in a arid region, or called as a what do we say that? Called as a dried or moisture, such kind of areas it has been pointed. Next is called as the third part, which is referring to another mode of formation, involves the decomposition of surface rocks, right? So that is deposition. This one is called as a decomposition of surface rock, and the removal of soluble constituents, leaving a residual mass of withered material containing ores. Containing ores. So if you talk about that, the removal of soluble constituents, leaving a residual mass of withered material. So residual means excessive or huge amount of materials which are, rotten, or you can say causing to die. That may be the carcasses, that called as a dead body of animals or birds, or you may talk about rotten vegetables, or wastage things, right? So all those things, material containing ores. Bauxite is formed this way, right? So you can point out that decomposition of surface rocks, certain things which have been kept for years, right, containing ores. Through that also we find out the minerals, right? So here it is stated that one of the example is called as a bauxite is formed this way. Next is called as a four, right? Certain minerals may occur as alluvial deposits in sands of valley floor and the base of hills. So these deposits are called as a what? Placer deposits. So which are called as a placer deposits? Now alluvial deposits in sands of valley floors and the base of hills are called as a placer deposits. And generally contain minerals which are not corroded by water, not been filtered by water, right? Or not been taken away by water. Gold, silver, tin, and platinum are most important among such minerals, right? So minerals like gold, silver, tin, and platinum are most important among such minerals which are drawn, right? Which are drawn on the basis of alluvial deposits in sands of valley. The fifth one is called as the ocean waters contain vast quantities of minerals, but most of these are too widely diffused to be of economic importance. However, common salt, magnesium, bromine are largely derived from ocean waters. The ocean beds too are rich in manganese nodules, right? So we draw that so far means five of the things, right, or five of the ways through which minerals have been collected, right? The first one is called as igneous rock or metamorphic. The third one is called as means sedimentary. Sorry, second one is called as a sedimentary, right? And the third one is called as when decomposition of surface rocks. Fourth one is called as alluvial deposits. Fifth one is called as ocean waters, right? Let's go for the interesting fact. So what is the interesting fact that we find out here? Now, rat hole mining. Do you know that most of the minerals in India are nationalized and their extraction is possible only after obtaining permission from or due permission from the government. So you can't do on your own. But in most of the tribal areas of the Northeast India, minerals are owned by individuals or communities. In Meghalaya, there are large deposits of coal, iron ore, limestone, and dolomite. Coal mining in Jowai and Cherrapunji is done by a family member in the form of a long, narrow tunnel known as rat hole mining. So, what is rat hole mining? That's indicating about means when the certain community or an individual, right, uh, do the kind of means do the kind of means job of what getting out the minerals, right, or owned minerals on their own. So in that case you can talk about uh, a kind of a process called as a rat hole mining. But at the same time, if you talk about rat hole mining, so it is indicating about means how the example of coal mining in Jowai and Cherrapunji is done by the family member in the form of a long narrow tunnel, right, which is known as a rat hole mining. So you need to remember the Jowai and Cherrapunji is the place where how family member means do the long narrow tunnel known as rat hole mining. Right. Next is called as India is fortunate to have fairly rich and varied mineral resources. So, however, these are unevenly distributed. Broadly speaking, peninsular rocks contain most of the reserves of coal. Right. So, if you see that what now India is hovered or means having with a variety of mineral resources, right? And these are not even properly distributed. So maybe some are excessive, some are less, right? Broadly speaking, peninsular rocks, which is taken as an example that how it contains reserves of coal, metallic, minerals, mica, and many other non-metallic minerals, right? So at the same time, if you go for the sedimentary rocks on the western and eastern flanks of the peninsula in Gujarat and Assam, you will find out the petroleum deposits. Rajasthan is the rock system of the peninsula, has reserves of non-ferrous minerals, right? The vast alluvial plains of North India are almost devoid of economic minerals. These variations exist largely because of the differences in the geological structure, process, and time involved in the formation of minerals. So it is giving us the clear idea that India is a place having with varied mineral resources, right? So whether you talk about coal, metallic coal, or you talk about petroleum, or you talk about non-ferrous minerals, right? These are the things are not been properly distributed based on the geological structure, right? So that is what it is pointed. Let us now study the distribution of a few major minerals in India. Always understand that the concentration of mineral in the ore, the ease of extraction and closeness to the market play an important role in affecting the economic possibility of a reserve. Therefore, to meet the demand, a choice has to be made between a number of possible options. When this is done, a mineral deposit or reserve turns into a mine, right? So, it is clearly given a kind of a concept that what? Now, the distribution of a few major minerals in India, right? What do we find out? Concentration of mineral in the ore, uh, the ease of extraction. So how many years they have been placed in a particular place, and how it has been, how difficult or how comfortability to extract, and also how means marketplace, the closeness to that particular minerals, right? So, and how it impact to the economic possibility, right? So therefore, obviously minerals completely depend upon the water demand, and also means availability, right? So deposit or reserve turns into a mine. When this is done, a mineral deposit or reserve turns into a mine. So based on that means availability, so place, and also importance. So based on that, the place is done as a mine. Next is called as a ferrous minerals. What is this ferrous minerals? When you look into that, so we find out that ferrous minerals means which have a content of iron, right? So ferrous minerals account for about 3/4 of the total value of the production of metallic minerals. 3/4, right? They provide a strong data for the development of metallurgical industries. India exports substantial quantities of ferrous minerals after meeting her internal demands. Let's say that one of the example is called as, or one of the minerals called as iron ore, right? Am I audible, guys, girls?
Yes, sir.
Soumya, can you hear me? Soumya? Soumya, are you there? Soumya? Is she there, Sneha? Yeah. Soumya, can you hear me? Hello? Okay. Sneha, are you listening to me? Sneha, are you listening to me?
Yes, sir, I'm listening.
Okay. So next is called as iron ore. Iron ore is the basic mineral and the backbone of industrial development. India is endowed with fairly excessive resources of iron ore. India is rich in good quality iron ores. Magnetite is the finest iron ore with a very high content of iron, up to 70%. It has excellent magnetic qualities, especially valuable in the electrical industry. Hematite ore is the most important industrial iron ore in terms of the quantity used, but has a slightly lower iron content than magnetite, right? So that's called as a 50 to 60%. So if you talk about that ferrous minerals, so we find out the first one is called as iron ore, and which is called as a common, and it is the backbone of the industrial development also. And we have abundant resources of iron ore, and we have a good quality also. So you can say that iron ore is nothing but backbone to the industrial development, and abundant resources, and also good quality iron ores. Magnetite is the finest iron ore with a very high content of iron, up to 70%. Even it has excellent magnetic qualities, especially valuable in the electrical industry, right? So where do we use this magnetic or magnetite? Now, especially in the electrical industry. Hematite ore is the most important industrial iron ore in terms of the quantity used, but has a slightly lower iron content than magnetite. Now, if you see that the this pie chart, which is indicating about iron ore production, right, state-wise and their share in percentage. And it is the data which is a uh, presentation of 2009 and 10. If you look into it, means first is Odisha, right, which have a 33% excessive, right, or the most or the highest means of production. Second is called as a Jharkhand, 28%. Then third is called as a Chhattisgarh, having with 19%. And fourth one is called as a Karnataka, 11%. And the rest is called as others. It means other states which have a means amount of ore production, which is 9%. So this is what is indication of what production of iron ore in a percentage. But this may be differ in the present situation as far as the share in percentage. Okay, now look into this one. What do you find out? It's a given of a kind of a fact. Kudre in Kannada means a horse. The highest peak in the western ghats of the Karnataka resembles the face of a horse. The Belladilla Hills look like the hump of an ox, and hence its name. It's called as a Belladilla, right? So if you see that, why it is pointed, or why does it the picture show? Now this picture shows that how means iron ore is mined here, right? Or you can say that means this is the place where the mining occur for the ferrous minerals. The major iron ore belts in India. So this kind of a place is also known as a belt, right? The major iron ore belts in India are. So you would find out that the first one is called as, on the basis of the picture, we find out that Odisha Jharkhand belt. In Odisha, high-grade hematite ore is found in Badampahar mines, in the Mayurbhanj and the Keonjhar district. So those are called as mining areas. In the adjoining Singhbhum districts, Singhbhum district of Jharkhand, hematite iron ore is mined in Goa and Noamundi. So you can talk about that Odisha and Jharkhand belt is considered as a major iron belt. The second one is called as a Durg Bastar Chandrapur belt, lies in Chhattisgarh and Maharashtra. Like on the basis of this pie chart, we draw the idea that how iron ore differs from means state to state. Very high grade hematites are found in the famous Bailadila range of hills in the Bastar district of Chhattisgarh. The range of hills comprise of 14 deposits of super high grade hematite iron ore. It has the best physical properties needed for steel making. Iron ore from these mines is exported to Japan and South Korea via Visakhapatnam port, right? So you find out two of the major iron ore belts which have been read here. Now, one is called as Odisha Jharkhand and the second one is called as Durg Bastar Chandrapur belt. So the third one is indicating about Ballari Chitradurga Chikmagalur, right? So Ballari Chitradurga Chikmagalur, right? Or Tumakuru belt in Karnataka. So normally we can say Karnataka has large reserve of iron ore. The Kudremukh mines located in the western ghats of Karnataka are a 100% export unit. Kudremukh deposits are known to be one of the largest in the world, right? The ore is transported as a slurry through a pipeline to a port near Mangalore, right? So these are the places which are famous for the region of what means iron ore mine and also called as a export, right? The next one, Soumya, are you there? Soumya? Okay. The next one is indicating as a Maharashtra. Maharashtra Goa belt. Includes the state of Goa and the Ratnagiri district of Maharashtra. Though the ores are not of very high quality, yet they are efficiently exploited. Right. Iron ore is exported through Marmagaon port. Right. So you would find out 4 of the areas which have been considered as the place for iron ore, major iron ore belts. Right. Sneha, can you tell me that what are those 4 major iron ore belts? Can you say?
Yes, sir.
Tell me. 4 major, you can say that iron ore belts. So
Sir, can you repeat the question?
My question is called as tell me 4 major area, right, of iron ore belts in India.
Sir, Odisha, Jharkhand belt, Durg, Bastar, Chandrapur, and Ballari, Chitradurga.
So you can say that Odisha, Chhattisgarh, Karnataka, and Maharashtra, Goa. Then
And Noamudi.
okay. Here, Odisha, Chhattisgarh, Durg, Bastar, which is Chhattisgarh and Maharashtra. Third is called as a Karnataka, and fourth one is called as a Goa and Ratnagiri. Then we move to the next one. The next one is called as a manganese. So if you look into this, manganese is mainly used in the manufacturing of steel, right? Why manganese is used? Now, manganese is mainly used in the manufacturing of what? Steel and ferromanganese alloy, right? Nearly 10 kilogram of manganese is required to manufacture 1 ton of steel. Please do remember that, right? 10 kilogram of manganese is used for 1 ton of steel. It is also used in manufacturing bleaching powder, which one? Manganese, insecticides and paints. So for which manganese is used. Now, if you talk about this, so this is the pie chart which is indicating about production of manganese, showing statewide share in percentage, right? So like iron ore, which where Odisha and Chhattisgarh, or Odisha is carrying with the major share by share in percent. Similar to that, if you look into the manganese, so here you would find out means Madhya Pradesh, Odisha, again, Odisha takes 25%, the major shareholder or major share in percent, right? After that, you will find out Madhya Pradesh, third is called as a Karnataka. Others 29% means, so we can say that if it distributes share in percent other states, so we find out 29% coming out from the others. Odisha is the largest producer of manganese as well, right? So manganese ores in India, it accounted for 1/3 of the country's total production in 2000 to 2001. So it would be change means if you look into the then and the present situation. So now, so far we understood about ferrous minerals. So, and under the ferrous minerals, we talk about what? Now, those of the minerals like iron ore and manganese. And we also draw that iron ore means where the major share in percent, you would find out Odisha, right? Similar to that in manganese also, you find out the major share refers to the Odisha as well. Next, we go for the non-ferrous minerals. So what is that non-ferrous minerals? Now, if you talk about non-ferrous minerals, India's reserves and production of non-ferrous minerals is not very satisfactory. However, These minerals, which include copper, bauxite, lead, zinc, and gold, they play a vital role in a number of metallurgical, engineering, and electrical industries. So we will discuss about the distribution of copper and bauxite. So India reserves and production of non-ferrous mineral. So the first negative point is called as we don't have much, right? Production and reservation of non-ferrous minerals, right? So despite that also, we find out that the minerals, non-ferrous minerals play a vital role in a number of metallurgical, engineering, and electrical industry. Let's see that. So when we talk about this non-ferrous minerals, copper and bauxite also are counted. Now, look into it. It is one of the picture of India, important minerals. So these symbols are pointed about iron ore fields, iron ore mines, iron ore exporting ports, manganese, bauxite, and mica, right? So you can see that iron ore mines like Ratnagiri, Goa, Ballari, Chitradurga, Kudremukh, Chikmagalur, and Turmakuru. So simultaneously here also you would find out Chandrapur, Durg, Keonjhar, Mayurbhanj, Goa, all these areas. So like similar to that manganese, where do you find out manganese? Goa, right? So other places also you need to observe that. So how in India distribution of iron ore, manganese, bauxite, and mica are presented. Now, the next one, you would find out non-ferrous minerals, and under that you will find out the first one is called as a copper. India is critically deficient in the reserve and production of what means copper. Critically deficient means we don't have much. Being malleable, ductile, and a good conductor, copper is mainly used in electrical cables, electronics, and chemical industries. So now you understand that the uses of copper is somehow called as a highly needed, but at the same time means we are losing, right? We are critically deficient in the reserve and production of copper. Let's say that the Balaghat mines in Madhya Pradesh. The Balaghat mines in Madhya Pradesh, Khetri mines in Rajasthan, and Singhbhum district of Jharkhand, they are leading producers of copper, right? So these are the places which are indicating as a means non-ferrous copper is availability and also means production, right? So the next one we talk about bauxite. So though several ores contain aluminum, it is from bauxite. Several ores contain aluminum. It is from bauxite, a clay-like substance that alumina and later aluminum is obtained. So first bauxite, and then after you get the aluminum from it. Bauxite deposits are formed by the decomposition of a wide variety of rocks rich in aluminum silicates, right? How bauxites how aluminum silicates are drawn. Now bauxite deposits are formed by the decomposition of wide variety of rocks, right? So, and those decomposition of wide variety of rocks rich in aluminum silicates, then only we find out means bauxite deposits, right? So next is called as aluminum is an important metal because it combines the strength of metals such as iron with extreme lightness and also with a good conductivity and a great malleability. So it tells about nothing but the feature of aluminum, right? So how aluminum is used, or means what are the things contained in aluminum. India's bauxite deposits are mainly found in the Amarkantak Plateau, Maikal Hills, and the plateau region of Bilaspur, Kathni. This is the pie chart that gives the description of what? Jharkhand, Madhya Pradesh, others, and Rajasthan. So if you see that Rajasthan is the place where the production of copper, right, percentage is highest. So second is Madhya Pradesh. Then the third one is indicating as a Jharkhand, then Madhya Pradesh, then others, 7%. So if the percentage is segregated, we find out Rajasthan is the highest, where 48%, what? 48% copper share. So second is Madhya Pradesh, where 29% of copper share, production of copper share. Jharkhand 16% is the production of copper share. So others are 7%. Now, Odisha was the largest bauxite producing state in India with a 34.97%, right? So 34.97% of the country's total production in 2009 or 10, right? It means it will vary if you look into the present year. Panchpatamali deposits in Koraput district are the most important bauxite deposits in the state. That is what we find out here. This is called as one of the bauxite mine. Okay, we'll keep here and we'll continue in the next class, rest of the things. Do you understand, guys?
Yes, sir.
Arey, where were you? I called you so many times. Soumya, did you hear everything or not?
Yes, I did.
Okay. So please keep this in your mind that we have done till 55.
So you said,
Yeah.
also you said that you were going to share the PPT of the like a
Notes.
presentation PPT of the
Notes. No.
Yes, sir.
Okay. Yesterday I forgot that. So tomorrow is Sunday, so I'll do it tonight. Okay.
Yes, sir.
Okay. Bye for now. Meet you in the next class. Till then, bye-bye. Thank you.
Thank you, sir. Thank you, sir.